Hello everyone. My name is Eray Tüzün. I'm an assistant professor at Bilkent University in Turkey. Today, I will give you a brief introduction of our recent paper, Closing the Gap Between Software Engineering Education and Industrial Needs, published in IEEE Software. New software engineering graduates go through a major transition from school to industry. When they are at school, they are faced with instructors, classmates, and teaching assistants. Whereas in real life, they are faced with real users, managers, and colleagues. In university, software processes are often idealized and have strict rules. Whereas in real life, often companies use their own hybrid type of processes, and you need to be pragmatic to be successful. The longest project that you would have in a school is most probably at most 3 months, whereas in industry, a typical project will last many years. Maintenance of a software project is almost never a concern in a university setting, whereas in industry, this is reality of every day. Because of all these reasons, many recent software engineering graduates often face difficulties when beginning their professional life due to misalignment of the skills learned in university education versus what is needed in the industry. In this study, we are answering three important questions. First, we want to know which skills are most important in the software industry. Secondly, we are looking for evidence of knowledge deficiencies in graduating software engineering students. And finally, we want to know to what extent are soft skills important in addition to hard technical skills. The quality of the software engineering workforce is a direct result of the quality of the software engineering education and how software engineering students are trained in university programs. In the last 25 years, there has been many studies to assess the readiness of software engineering curricula for industry. We believe that it is important to synthesize and aggregate the results of all these studies to provide a single consolidated view. To provide this consolidated view, we conducted a systematic literature review of the studies that focused on aligning software engineering education with industrial needs. Our search string included educational and knowledge needs, desired skills, essential competencies, knowledge requirements, skill requirements, and software engineers or software developers. Here, we excluded papers based purely on personal opinions. We only included papers that were based on empirical data, such as survey results or interviews. After a careful analysis, we end up with 33 studies that address this issue and satisfy our search criteria. These 33 studies were published between 1995 to 2018, and they are from 12 different countries. The number of total respondents represented in these studies were more than 4,000. The questionnaires designed for and used by the studies had differences with respect to the concrete software engineering topics used in them. In other words, when asking respondents to rate or rank the importance of software engineering topics, different papers use different sets of software engineering topics. With such diverse software engineering topics used in these studies, we selected the most relevant software engineering body of knowledge version 3.0, and we mapped the software engineering topics discussed in the papers to the 15 knowledge areas listed in here. The next step was consolidating the quantitative data of skill importance from all of the papers. To be able to cross-compare and synthesize data in a consolidated way, we harmonized the importance of ranking data. This figure shows the normalized average importance versus ratio of the papers. Here we have some interesting insights. We observed that requirements, testing, and design are the most important and are frequently mentioned in the primary studies, whereas software engineering economics and mathematical foundations seems to have less importance. In the next graph, we plot importance versus knowledge gap and divide the graph into 4 quadrants. Topics in quadrant 1, which are high importance and high gap, these are the ones that would require the most attention with respect to the need for improvements in software engineering education in university programs. Some of the examples in this quadrant are configuration management, software engineering process, design, and testing. Topics in quadrant 2, which are low importance and high gap, should be the next focus with respect to software engineering education. They have relatively low importance, but high knowledge gaps in these topics remain, thus need attention for more education and training on these topics, such as software engineering models and methods and maintenance. For topics in Quadrant 3, university programs are generally doing a good job, since knowledge gaps in these topics are relatively low, while they are quite important with respect to technical needs in the industry. Topics in Quadrant 4 have low importance and low knowledge gaps, so they are least in need of improvements and the attention of software engineering education in university programs. We also analyzed the primary studies in terms of soft skills. Majority of the studies emphasize the importance of soft skills. Teamwork and communication, leadership, and critical thinking were the most common soft skills deemed important in the industry. The other important skills include cultural fit, understanding of business drives, aptitude, attitude, coping with ambiguity, learning and curiosity, and passion and drive to innovate. So eliminating important knowledge gaps for various software engineering topics ultimately helps us to understand how we can best train future software engineers. By summarizing what we as a community know in this area, this article aims to benefit the readers, which are both educators and hiring managers, by providing the overall state of the community with respect to aligning software engineering education with industrial needs and documenting the body of knowledge in this area. So the key takeaway messages are: knowledge gaps do exist between software engineering education and industrial needs. Software requirements, design, and testing are the most important skills. The greatest knowledge gaps are in configuration management, software engineering models and methods, software engineering process, design, and also testing. If you're curious about exploring this knowledge gap and find out more about the details, please check out our paper at IEEE Software, and please feel free to ask questions through Twitter or email us. Thank you for listening.